So live stream is about to start. Okay, looks good. So welcome again to our Cloud Native Rosenheim meetup today. Today we will talk about Kubernetes 1.23 and all things new about it. Before we start, who are we? So basically, my name is Nico Meisenzahl. I'm Senior Cloud and DevOps Consultant, Microsoft MVP and GitLab Heroes, doing all things Cloud Native, Container, Kubernetes, and Azure. And together with me, Phil is doing the meetup today, but over to you, Phil.
Yeah, hi everyone. My name is Philip. I'm also working at White Duck. I'm a Senior Kubernetes and DevOps Engineer. I'm also a GitLab Hero. They're owning a few Kubernetes certificates. And my daily work is around Azure, Kubernetes, and Cloud Native stuff.
Cool, thanks. So just some housekeeping stuff. Once again, this meetup is streamed to YouTube, just in case. Stay muted or turn off your video if you would like to be part of the stream. But if you have any questions, and don't hesitate to unmute and ask your questions. If you're joining us from YouTube, feel free to join our Cloud Native Rosenheim meetup community to get access to this Zoom meeting we are in. Then you can basically ask questions, unmute yourself, and join the community. If you're on YouTube, we also monitor the comments over there. So in case you have any comments, just put them in YouTube or also in the Zoom chat. Okay, so the agenda today, first of all, we're doing currently overview of Kubernetes 1.23 release. So just some basics, and then we're doing a deep dive in some of the features. So basically our picks. Some nice features. We included some demos on some of them, so to give you some more insights and some more hints and details. Of course, we also have some deprecations, which we also would like to talk about to make you aware of them. And last but not least, we have some further topics around the release, some hints, details you should know about when using Kubernetes or when upgrading to Kubernetes 1.23. Okay, so with this, it's all about Kubernetes 1.23 today. So basically, this release continues the Star Trek theme, which we already know from the Kubernetes releases. So multiple releases, and the whole history of Kubernetes is somehow related to Star Trek. So this time, the release logo basically has a ship in the middle, which basically means it's the collective teamwork around the release, for the release team building up this Kubernetes release. And every star on the logo, it's hard to see at the moment because it's so small on the right corner. Basically, every star is a Kubernetes logo. So it's pretty nice logo, in my opinion, at least. So the release has been released end of last year, so December 7. So it's out there for them some weeks or months now. It was the third release last year. It was the second one after shifting from the 4 releases a year shift to 3 releases a year. So basically, it was the third and last release in the last year. Now we also have some patch releases already available, but basically we thought about doing a meetup early this year, talking about the features, because not everyone has upgraded to this release, and also the big cloud providers do not yet, or not all of them yet offer this version. So we thought it might be good timing to give you some more details and insights. So what do we have in this release? We have 47 enhancements, 11 of them created to stable. So they are therefore stable, ready for production. We have 17 moving to beta, 17 entering as alpha. So basically 17 completely new features which got introduced in this release. And we also have 1 feature which has officially deprecated. In this release, we do not have any removals. Last time we talked about Kubernetes 1.22, we also had removals, so basically features and API versions which got dropped from the release. This time we only have a deprecation you should be aware of. Which is also nice is that with this release, Kubernetes now complies with a supply chain level for software artifacts level 1. So this is basically something around making sure that your software or your software artifacts are secure and do not have any supply chain related issues in place. There are multiple levels. Kubernetes now has the entry level, level 1, which basically means that the project ensures to have a fully scripted and automated build and release pipeline and provides evidence. So basically it's the first layer, but of course you need to start with this topic. So basically getting the first layer, the level 1, is a good one. And I'm pretty sure the Kubernetes team will work on getting higher levels over time. We also included a link here to give you some more details, or we can read some more details on the different levels and the whole project behind it. So it's also a really, really nice thing. So just a short intro. So let's get over to the real features and our pick of these features. With this, over to you, Phil.
Yeah, so basically when we talk about enhancements and features, we also have to talk about the Kubernetes feature states. Basically when new features come to life, there are ideas, then they are written as issues on GitHub as Kubernetes enhancement proposals. It's also called KEP. And when the KEP is written and the issue is opened, they are worked into code. And when the code is finished, then we have an alpha state of the feature. These features are not enabled by default on the API server or on the Kubernetes components. So we have to opt in to these features and enable them. The downside is that when you have a managed Kubernetes like Azure Kubernetes Service or Amazon EKS, that the vendor may decide what features you get. So you cannot enable those feature gates, which are in the alpha lifecycle. The beta ones are enabled by default. You still have the option to opt out if you don't want these features to be enabled. And when the beta phase is over, there's a commitment that these features are staying in place to the current major version, and they are called then stable or general available. So when we go to the first feature, which graduated to stable, is the dual networking stack. So you can now natively run IPv4 and IPv6 in your cluster. The downside or the what you need is that the container network interface, the CNI, need to have support for this. Has built-in support for this. My God, sorry. So the KubeNet, for example, when you have Azure and RKS, or Calico when you also use AKS, or I don't know, vanilla Kubernetes on your own VMs, this network CNI, the CNI need to support this. Also, the nodes must have routable IPv6 and IPv4 network interfaces, and by default, the API server and the services still are in single stack mode, so you have to opt in and enable the dual stack function on those on the API server and the services. More you can read on those links we provided. There's a discussion with Tim Hockin, for example, who was deeply involved in the dual network stack. I think he's well known in the Kubernetes scene, and also some concepts of the networking and dual stack mode. So if you want deeper information here, check out the URLs provided.
Okay, next one, ephemeral containers. So this feature we already talked about in one of our last meetups and also did a demo, but now it graduates to beta, which is of course nice because now people using managed offerings can also use this because it's enabled by default. So you can use ephemeral containers to for multiple purposes, but one of the biggest one is to use this when debugging your Kubernetes workload. So basically it's integrated with the kubectl, and you can do a kubectl debug and then add an ephemeral container into your pod. And then this also allows you to basically share the process namespaces with your main container, let's say this, and then use this to debug. So you can spin up an image with your favorite tools, favorite dependencies and all the things you need to debug. So basically, I don't know, spinning up a full-blown Ubuntu, installing some debugging tools in there, and then use this container with all the debugging tools and attach it to your main process in the pod to then debug this. So it's a really nice feature to debug your workload, and helps you to not put some debugging tools and stuff like this into your main container image in your main process, which you of course should not do. Now, where it creates to beta, we have it in place by default and by default, and can start using it. If you would like to get a demo and more details on that one, you can see our recording from our Kubernetes 122 meetup, where one of our colleagues did a nice demo on that one and showed it in more detail.
Okay, traditionally, Kubernetes offered us unstructured logging, and with the alpha introduction in 1.19, the feature of structured logging was introduced and is now beta, so it's enabled by default in the new release. And what we get now is we have structured logs with key value pairs and object references, and we can also opt in and at the API server that we want log output in JSON format. The benefit we get is that we now can automate the log processing better with structured logs because they are predictable, basically. And if you want to check out more, you can check the blog entry from the Kubernetes official blog.
Okay. So next one is generic ephemeral volume feature. This one also creates the stable, so it's now in GA. It's therefore, of course, enabled, ready for production usage. So what is this feature about? We all know ephemeral volumes in Kubernetes. So basically, empty directory or a secret or config map and stuff like this. And there are also different implementation by CSI, so container storage interface available. With the generic ephemeral one, basically there's one generic version or option to enable ephemeral volumes. So it's not that you, need an implementation if you're using a specific container storage interface. So it's basically a generic implementation. Many container storage interfaces or CSIs will support and have basically a common language about what they are about to support here. So it's basically can be either local storage or network attached storage. You can define a fixed size for every pod as a limit. You might be also able to configure some initial data. This, of course, depends on the CSI implementation, and you get all the features provided by CSI, like snapshotting, cloning, resizing, and stuff like this. So basically, it's a feature which allows you to get ephemeral volumes in a generic way without using any kind of specific implementation. So it's a pretty nice feature which makes life a little bit easier.
The pod security admission controller, which was introduced in the last release as alpha, now graduated to beta. The pod security admission controller is the successor of the pod security policies. And we did a deep dive on this with the demo on the last meetup we had for 122. So basically a short overview is that the pod security admission controller provides us with 3 different policy bases. It's privileged, baseline, and restricted. And we can enforce them with 3 levels. We can enforce, so everything will be blocked. For example, if you use the restricted, we can audit just, and we can enable the warning level where we get, for example, warnings in a CLI. And if you go one slide more,
sure.
One slide further, there's the URL for our last meetup as we talked, and here's also, we did an introduction, what is admission control and how is it working in Kubernetes and how the pod security admission controller works, and we also made a demo. So if you want to check it out, I can recommend to rewatch our meetup from last time.
Perfect. Then also a nice feature, skip volume ownership. although this one is graduating to stable and therefore production usage. What is this about? So basically, every time a pod is starting or container starting, Kubernetes will set volume permission and ownership and stuff like this. And if you have a really big volume attached to your workload, this might take some time. It basically lowers the speed of your container or pod startup time. And with this setting, so it basically can be specified in the pod specs, security context section. You can then disable this and make sure that the permissions and ownerships are not set every time. So it's really nice to speed up the pod start for large volumes, but also there are some deployments, databases where changing the ownership and setting the permissions might get you into some trouble. Also for this workload, it's pretty nice feature to be able to disable that one.
Okay, with the 123, we get a stable feature, which is called the TTL controller, the time to live controller, which is responsible to clean up finished or completed jobs. So we all know the jobs, and it starts pod, and when the pod is finished, they have a completed or uncompleted status. And if we have a large amount of those jobs in this pod lingering around in our Kubernetes control plane, it can cause cluster performance degradation. So it's like a load on the API server is much higher if we have 1,000 pods there. So we can specify seconds after time to live, seconds after finished of the job when we want them to be deleted. So if we set the field value to 0, for example, the job will be immediately deleted, or we can also specify, I don't know, 1 hour, and then we could check the status of the jobs and then delete them automatically. So this is a cool feature if you have a high amount of jobs running in your clusters to get them automatically removed finally.
Okay, so next one is related to CRDs, custom resource definitions, and it's a new feature, so therefore it's an alpha feature, which means you of course need to enable it. So there's a feature flag called custom resource validation expression, which you need to enable on all components to use that one. So what is this about? Basically, expression language validation allows you to define validation rules within your custom resource definition. So to define any kind of rules, which is allowed or which is not allowed if you create a custom resource. So far, this is basically most of the time implemented using webhooks. So basically, you have your custom resource definition, and then you have a webhook which validates a custom resource after when it's applied to the Kubernetes API server. So basically, you have the custom resource definition, you have the webhook, so you have two things you need to maintain. If you would like to make sure and to somehow validate your custom resources, and with the expression language validation, you basically can most of the time basically remove the webhook and define everything in a so-called, let's call it self-contained custom resource definition, because basically the definition itself and the validation rule is configured within the CRD. So basically, maybe not a feature everyone needs, but if you are into custom resource definitions or you're using any kind of open source tools relying on those, it might be really helpful and maybe also removes some kind of complexity by the additional webhook. Here, one example in the screenshot. So this is basically how it could look like. You have the X Kubernetes validation rule section here, and there is a rule which defines basically that the replica count should be smaller or equal to the max replica count. This is something you could implement with the expression language validation. If you basically would like to implement it without that one, you would need a webhook checking every time if the replica is smaller or equals the max replica count. And now we can basically add this information, this validation directly into the custom resource definition. If you would like to get more details and the language validation itself, we also added the link here to the Google project.
Okay, a small one for the Windows forks. We have now Windows container privileged support, which graduated to beta, so it's enabled by default. It allows us to run privileged Windows containers. Although we have this feature, it should not be required for normal workload. It's a recommendation, but it opens up flexibility for third-party integrations, for example, security things, monitoring things, which may need privileged containers.
So then another great feature, server-side field validation. This is also something which you might not need when you're just working with Kubernetes. But if you're implementing something and talking directly to the Kubernetes API server via REST or something else, this could be really helpful. It allows you to basically, what will happen is that when you send a request to Kubernetes, the Kubernetes API server, the API server will validate this request, or you can opt in to tell him to validate it. And with this, basically, you do not need to implement the validation in your application and then make sure that you send something validated to the Kubernetes API server. So basically, it's a server-side version of kubectl validate, for example, but not implemented in kubectl because that's integrated on client side anyway. But if you're implementing something in your application and talking to the Kubernetes API server, you now do not need to care anymore about the client side validation and just tell Kubernetes how to validate it. It's a new feature, therefore, once again, alpha feature, and you need to enable it with the server-side field validation feature kit. And then if you do so, you can basically add on a query parameter to your request called field validation and tell Kubernetes if it either ignores, warn, or should deny the request. And this is something I would like to show you in more detail in a short demo. So 1 second. Let me share my VS Code here. Okay. So what we will do here. First of all, we are starting up kubectl proxy. So if you don't know kubectl proxy, it's basically exposes the Kubernetes API server on my local machine and do all the things around authentication that I do not need to care about it. And now I'm basically able to talk to my Kubernetes cluster exposed on my local machine on port 8001. So now we basically have just a pod definition here, which we are putting into our curl command, doing a post, and sending it to our Kubernetes server, which is exposed locally. And there's one thing which I added. So basically everything is a normal pod definition, except that we have another field here, which is called unknown field. And basically I was here. So basically nothing which is somehow implemented in the Kubernetes API. But let's see what happens. So copy pasting this one here, just make sure I'm on the right cluster. And hitting enter. So what will happen is that we will get the pod. So the pod is creating. If we're now checking the YAML here, we will see if we go to the container itself. 1 sec. That basically Kubernetes just dropped the unknown field. So there was no warning, no error message, no deny, nothing further, just the unknown field was removed, which is okay if you are aware of it. On the other hand, if we, I don't know, would have not an unknown field, but multiple image fields, for example, then basically Kubernetes would use the latest one. So if there's an Nginx 1 and an Nginx tag 2, basically the Nginx tag 2 would have been deployed. So if we now get one step further and doing the same curl command, once again with an unknown field, and just add a query onto our URL with field validation strict in this case, we now shouldn't be able to create this pod because we still have the unknown field. And if I do this again with the field validation query parameter, we're getting an error message from the API server telling us that the pod version v1 cannot be handled as pod because there's an unknown field called unknown field. And we get an error code 400. So with this, you can make sure that basically invalid definitions are not applied, but you also don't need to implement it on your client side. So pretty nice feature if you're working with the Kubernetes API server. Okay, with this, back to Phil.
Yeah, CronJobs. I think we also talked in the previous point about it with the TTL controller. CronJobs are finally graduating to stable. They are introduced since Kubernetes 1.4. They are beta since 1.8, and we have a V2 implementation of the CronJob API since Kubernetes 1.21. And yeah, we talked about CronJobs are especially or basically are jobs or pods running inside Kubernetes on a scheduled base, and yeah, they are now stable. So it's a commitment that they are not removed. Finally,
would be bad.
Yeah.
Okay. Yeah. Once again, a small update on CSI container storage interface. As you all know, container storage interface is the new thing how to integrate with storage. And therefore, there's a migration path for different providers. And just added this slides because there were some updates in this release related to the migration path, and I thought it might be nice to have it in here. So if you're talking about the availability, most of the features or most of the implementations move to better here, except the OpenStack part, which basically allows us to be enabled by default that we can really use those to migrate our existing persistent volumes to the CSI implementation. Most of them, once again, or the important ones are moving to stable in 1.24 in the next release. And then after this, any one of them will be removed, or the entry plugin will get removed in 1.26 or 1.27. So if you're using some volumes which are not integrated with CSI, make sure to migrate them. It's really nice option. So at least I know it from the Azure side. It's completely seamless. So it's a really nice thing, and also now enabled by default and better.
Okay, the next feature is called kubectl events. kubectl events or kubectl events is a alpha feature. So we can, it's a command basically. It's a reimplementation of the kubectl or kubectl get events command. So you can call it with kubectl, kubectl alpha events. And this new implementation or reimplementation addresses long features or long address features like filtering, watching, sorting. So when you do a kubectl or kubectl events, they are not sorted, for example, from the time. So it was really hard to see what's going on. And yeah, this event subcommand will help improve user experience. So we can do a short demo here on this one. Yes, and you can see on my screen now. So what we can do is we create a new namespace, and then we can run. What was it? Nginx01 was your name, right?
I think yes.
We just run a pod here, and then we say Nginx.
Okay, it was -1. Yeah. Sorry.
No, I have to select the right namespace. define the namespace. And what we see now here is when we do kubectl get events. Now we are lucky, maybe. But when we see the new command, alpha events, we see that it is better structured. Yeah, here, okay, let's do in the whole cluster. Maybe my size is too big. So what we see here now is that the events are sorted in from a time frame. So the latest events are at the bottom of the screen. And when we do a normal get events, we see that they are not sorted. So at the bottom is 2 minutes, 9 seconds ago, something was failed, and 40 minutes ago. So it was really hard to see the life cycle of the events, what is happening right now and which time. So you have to always check time, and the new command is a real improvement here. So you see that we have some Longhorn issues, but this will not bother us now.
And which is also nice that you have -4, I think it is, or Phil?
Sort, or what you can.
I think -4, which you then can allow use to select an deployment or just a pod or so, and also doing a watch now.
Specific resource. Yep.
So really nice one.
We can also make a watch. So we can make a for and combine those with watch and all namespaces. Yeah, we have it already with the -A. So yeah, this will be, hope this will be evolving better and will become stable soon, because this is really a nice feature which will help you on the daily work with Kubernetes. Okay, back to you.
Yeah, let me share the slides again. Okay, this was the Dario. Another nice feature is priority and fairness for the API server requests. This one is also graduating to beta, so it's therefore enabled by default. This allows you, if you have an high workload on your cluster, you can with this granularly define which API requests are prioritized or are not prioritized. So as you see in the example on the right, so basically on the lower part, you have the request priority, where basically you can define some priority, let's say priority classes, defining them some specs here, and then on the upper part, you basically in this case defining the request priority with name lower and match it to a specific user, which could be a controller, a service account, or something else. So just a small example. So basically, you can really define in detail which user or which controller should be prioritized when there's high load on the API server. Now enabled by default is better. If you already have used it, there were some major API changes in the alpha phase. So if you already used it in alpha, make sure to update your definitions to the new API beta version.
Okay, another cool feature is to auto remove PVCs, so persistent volume claims, which are created by StatefulSets. So it's a new feature. So it's an alpha lifecycle state, and we have to enable it with the StatefulSet auto delete PVC feature gate on the Kubernetes components. And this controls the lifecycle of PVCs created by StatefulSets. So often we have StatefulSets and PVCs, so in our StatefulSets we have persistent volume claims, which are creating persistent volumes, and when we delete this, sometimes it's forgotten to remove the PVCs, for example, or we have the need of creating temporary PVCs, and often they are just not removed. And with this, we can specify a spec section of the StatefulSet, a new value, and I will show to you. And this deletes the PVCs and the PVs then. Then let me share my screen again. Hope you can see. So what we have, I have two stateful sets deployed. So one I just called delete. And when we just look at this, we have a new section here in the spec. It's called persistent volume claim retention policy. And we can define when the persistent volume claim is deleted, we also want to delete the PVC. The stateful set is deleted, sorry, or when it's upscaled or downscaled, we also want to delete the PVCs here, the persistent volume claims, which are defined here. And then we have the same with the stateful set, which I just called no delete. And we have the same section here. So this is the default behavior now when you enable the feature gate. Persistent volume claim retention policy, and we say when deleted or when scaled, we want to retain the PVC and the PV. And when we go now here and delete our stateful set, for example, the no delete one, and then we delete the delete one, then we can make a get PV and PV, PVC, PV. And we will see maybe a little bit smaller, it's a little bit better maybe. We can, sorry, just make it a little bit more overview. So we can see that our persistent volume claim delete is not there anymore. So just the no delete is here, and the persistent volume of the delete is it's released. Yeah, so the persistent volume is not mounted anymore, and so it's there, but it's not deleted. Sorry. The different way. We have to wait a little bit. So yes, now I got it. The delete one was deleted because we say we want to delete it, and the no delete was not deleted because we want to say retain. I was a little bit too fast on the on the outcome. So again, here we have the persistent volume claim, which we specified with no delete here, and the persistent volume here. So our data, let's say, is safe. And our temporary persistent volume claim and persistent volume, which we wanted to delete, are gone. So this is a nice way to check that the available storage is maybe not over provisioned, and you have some issues when you provision new persistent volumes that you have no space. So you can just mark them as delete, and then you're good to go. Okay, back to you, Nico, then.
Yep. Let me share again.
Yep.
So next one is OpenAPI with re-support. So far the Kubernetes API used OpenAPI API version 2. Now we're getting version 3 support if you would like to. This is also a new feature, so in alpha, and if you would like to use it, you will have to enable it with OpenAPI v3 feature gate on all components. So with this, basically, and so far, it's the most important use case to use it is for really complex custom resource definitions, where you might need to define some more complex things which are not supported in OpenAPI v2. This could now be understood by the Kubernetes API server. So far, before enabling this, you could define your custom resource definition in version 3, but then basically some information got dropped because the API server is just aware of version 2, and this could be resulting in missing informations. So there might be some custom resource definitions in the future which might require you to run OpenAPI version 3 on your Kubernetes cluster. But now it's just a new feature enabled or not enabled by default. If you enable it, the API version 3 gets exposed on a different endpoint. So it's basically /open API version 3, your API, your groups, and then your versions of your resources. And there's also some updated spec on how the API endpoints get exposed to improve performance and further stuff. So I think it's a bigger change. It will pretty sure take some time until this is stable, but allows us to implement and define some more complex things, and especially with custom resource definitions.
Okay, then back to PVCs and PVs. We have a new feature which is alpha. So again, we need to enable it as a feature gate with the recover volume expansion failure flag. And what it will bring us is it allows us to reverse a PVC resizing if it failed. So sometimes we have the issue that that we want to extend a PVC, yeah, and then it's not supported by the underlying provisioner, and we get an issue, and then really hard to recover from this resizing issue. So what we now will get with this new alpha feature is that it can be possible to reduce or reduct the size to a supported size. So, but there are some restraints we have to match. So if the new value is higher than the capacity used, so for example, if we have a 2 GB PVC and we want to extend it to 500 and then we have a failure, we cannot reduce the size to 2 GB. So we have to say, for example, 3 GB. Yeah, and the PVC or the expansion status of the must be in a failed state to have this option enabled. I hope this was clear somehow. If not, just raise a hand and ask. So yeah, it's a little bit, it's in alpha state. So it's also, we have to check what is meant with unsupported PVC size. Yeah, so this has to be checked out. As they say, unsupported, it doesn't mean, let's say, over provisioned PVC. So I think, or we think that it's not a, just if you over provision the PVC and then will fail, then it will not happen. But there must be something else on the underlying storage infrastructure that it's called unsupported PVC size. So we have to check it out, and maybe when it's better, in a better state, make more tests on it.
Okay, last but not least, I think it's the last feature before we go over to deprecations is GRPC prop support. So until this release, there was no real option or no Kubernetes own option to use GRPC probes to make sure that readiness and liveness probes and startup probes and stuff like this are in place. With this feature, this new feature, basically, this will be, or the support will be added to the Kubernetes cluster. So once again, a feature gate, which you need to enable, which is also important. You also need to enable this one on the kubelet, because the kubelet is doing the health check. So I was testing around with this issue last weekend, and it took me, I don't know, 3 hours or so until I realized, okay, we missed to enable this this feature on on the kubelet. And there was just some strange errors going on. So basically, to get this work with your application, you need to implement the GRPC health checking protocol. So basically, I added a link here. It's just some proto which you need to implement in your application, and then show you in just some sec. And then basically, you will have some endpoints Kubernetes will use to validate if your application is up and running. So before this feature, there was an implementation called GRPC Health Probe, which is just was a CLI on wrapper, which you could add as a binary into your container image, and then use this wrapper CLI to expose your GRPC probes or health endpoints. With this implementation, you basically can skip this one and just implement the health checking protocol I linked above. Besides this, it's pretty, as you know it from HTTP and TCP probes, so you will have it available in readiness checks, you will have it available in liveness checks and startup probes. Only limitations so far are that named ports are not supported yet, and that TLS implementation is not yet supported. But besides this, it's pretty nice feature, and let me show it in detail. So maybe starting with GitHub here. So basically, I did a small implementation here, just some sample how to deploy it. So basically, we have a deployment here. We have a container which is based on the application in this repo. And then basically we have a liveness probe and a readiness probe here. Both of them are using GRPC. We have an initial delay seconds in here and define a port where to check. And all the magic you basically have to implement is basically this proto. So there's a Go package from Google, this one here, and you're basically just implementing a health check response with serving statuses for unknown serving, not serving, service unknown, or just some of them. And with this, basically, Kubernetes is able to verify. So this basically the server Go here, it's just a small implementation to show this live and demo. So feel free to check out this repo to get some more details on how to implement it. But with this one over to my VS Code here. Here, once again, it's just the deployment I just showed you. So we have the deployment file here. We are defining our container image from GitHub. We have container port 3000, and we also have the liveness probes GRPC port and the readiness GRPC port here. So let me copy that one. Oh my God. And applying this one into our cluster. kubectl get pods. We now have our house here. And if we do disk, I guess there was no just low. Okay, it's not yet ready. If we're waiting just some seconds, now it's ready and running. And also, if you can copy paste the name and doing an kubectl is scribe and check out. Okay, describe hot. Sorry. We're also seeing in the events here that we do not have any health check or readiness check issues. So basically, the pod is up and running, and Kubernetes knows when to restart it or when not to route any traffic. So I think this is an issue many people waited a long time. Now we at least have it in alpha available, but I guess this will move to beta pretty fast. Really nice one here. Once again, the link to the application. Also, I think I saw the link in or the question in the chat. We also have our slides and all the demos on GitHub. So maybe scroll up in the Zoom chat to find the link, but we'll also have it later in the slides. So with this, we are finished with our the new features we would like to talk about. But we still have some deprecations and further stuff left here. Deprecation, the first one is about the flex volume. Now, of course, we talked about CSI a lot. CSI is the future. Because of that, it's normal that flex volume gets deprecated. So if you're a maintainer using the flex volume, you should make sure to implement the CSI driver version of it. If you're a user using flex volume, you should make sure to migrate to a CSI implementation here. So just had a customer some weeks ago who used the blob integration with flex volume, which we now have migrated to a CSI version here. So really, container storage interface CSI is a successor of flex volume. It's more flexible. It's an out-of-tree implementation. So basically, updates and features can be shipped without being shipped within the Kubernetes version. So it's really nice, and it's a recommended way to use and integrate volumes in Kubernetes. I also added some more details here. There's a nice FAQ with some more details, but yeah, the future is CSI, so make sure to get rid of any kind of flex volumes integration you may use. Yeah, then not a big deprecation, but still nice to know. HorizontalPodAutoscaler v2 also created to stable in this release, which basically means we now have autoscaling v2 version available. If you're using HorizontalPodAutoscaler and you're using a better version like the autoscaling v2 beta 2, make sure to migrate to the stable version because the beta version was deprecated. There are some smaller changes, mainly related to field names, like resources was named to pod resource disabled to scaling disabled and stuff like this. So you might need to update your configuration, your specs a bit, but besides this, there were no bigger changes. Yeah, then on the client side, on the kubectl side, we all know kubectl --try run. Just using --try run is also deprecated. With Kubernetes 1.23, you will need to tell the kubelet how to try run it. So basically, you have 3 different versions. You can do a --try run none, but some you can basically just skip the --try run in front because it basically means disable try run. So not really helpful. But then we have a try run client. This basically really just does a try run on the client side. So basically just prints your definition without sending it to any Kubernetes API. So really just staying locally on your client. With kubectl --try run server, the request gets sent over to Kubernetes API server. So we'll need a Kubernetes API server in place you can talk to, but without persisting this underlying resource. So why is it an option you could do? Basically, when you send it to the server, you will get back all default fields. So anything you do not add but is default will be added there, and the whole validation and admission chain, like mutating admission controller and stuff like this, will be also checked. So with this, you can really make sure that also on the server side in Kubernetes API server, your manifest is validated and then printed out. So basically, you now have 2 options, either the client side or the server side. Yeah, and with this, back to Phil for some further topics.
Yes, I think we are the only 2 persons on the planet who say kubectl. Okay, this is a very specific topic, and maybe some are affected, some not. In Kubernetes 1.23.0 till 2.23.2, there was a regression that the Kubernetes API server drops unknown fields from list or array items in CRDs. So when you set Kubernetes preserve unknown fields true on the list or on the array, all these items in the array or list were dropped. So this is especially bad when you have develop CRDs who need those arrays and fields. And this was fixed in the release 23.1.23.3. So there's also a lot of GitHub issues there. For example, the issue we linked here was Kyverno, the policy framework, which had issues with the CRDs. And yeah, maybe if you are using or heavily depending on CRDs, maybe think skipping the releases and directly go to 1.23.3 to do not be affected by this dropping unknown field issue in the API server. And the last topic, which we always recommend if you upgrade to a newer version, and there are many API deprecations and so on. There's a nice tool. It's a plugin for kubectl. It's called kubectl convert. So you can install it as a plugin, and you can update your manifest to new API versions. I think Nico did a small showcase in our last meetup. So I again recommend to watch the meetup video or the recording of our meetup. There are some nice demos. And I think we are done with the slides, correct?
We have some further links.
Yeah, we have some further, you go.
Okay, so basically some further links. First one is our GitHub repo from this meetup. So you will find the slide deck, you will find the demos and everything all other versions, prior versions of our meetup. And then we linked some of the Kubernetes release blog posts, doing some deep dives in the specific topics, and also the Kubernetes blog post, 123 blog post from Twistic, which basically lists all features and no features and changes in detail, linking to the issues and caps on GitHub. So this one is a really detailed one if you really to deep dive into one of the features in more detail. Yeah, I think with this we are at the end, at least with our talk. But feel free to unmute, ask any questions. I don't think so far that I saw any questions in the Zoom chat, neither in YouTube. But if you have some questions, just feel free to ask them now, either in the chat or just unmute and verbalize them. Too much information. Yeah, it was a big release. Let's say it that way, or many nice features.
Yeah, the last two was really big, right? The last one was 64 enhancements and now 47.
Yeah, you're right. Okay. So then maybe I'm stopping the stream to YouTube. If you would like to stay in the Zoom, feel free to. We can continue discussing or start discussing on some things. But for the YouTube side, thanks for joining, and I'll see you next time.
Thank you. Bye.
Okay.